I want you to imagine that we live in a slightly different world than the one that we're in currently. In the world where we live right now, we have something called a speed limit. Speed limit says this. You're driving down the highway. You have to drive a speed that is strictly less than or equal to 45 miles per hour. However, imagine that instead we have something called a speed discontinuity. Here's what a speed discontinuity says. You can drive any speed you want. You just can't go 45 miles per hour. So you're on Telegraph Road and you're waiting at a light, and all of a sudden it goes green at time 0. And of course, since you've been waiting at the light, your speed at that instant is 0 miles per hour. But the second that that light turns green, you put the pedal to the metal. 2 minutes later, you are zooming down Telegraph. You're going 100 miles per hour. But you're cool, right? Because 100 is not equal to 45, so you're not breaking any laws. But all of a sudden, Officer Klein here, I couldn't help but notice that you're going 100 miles per hour. I'm going to have to give you a ticket. Dispatch, I'm dealing with a very difficult student here, calling for backup. See, here's the thing. You were going 0 miles per hour at the beginning of this interval, and you were going 100 miles per hour at the end of this interval. So it seems to me that somewhere on that interval, you must have been going 45 miles per hour. Now, I don't know when. Could have been early, could have been late, but at some time on that interval, we'll call that time x equals c. You must have been going 45 miles per hour. You broke the law. Here's your ticket. Value theorem. Intermediate meaning in the middle. Here's what it says. You have an interval. Let's say that interval goes from A to B. And suppose we know the values of the function at the start and the end of the interval. We'll call them f of A and f of B. And let's suppose that we also know that f is continuous on this interval. Then here's what we can conclude. If y is a number that is between f of A and f of B. So let's suppose y is right here. Then the curve at some time between A and B has to take the value y. And we'll call this time x equals c. So in other words, if the function's continuous and y is this number that's between f of A and f of B, then there is an x equals c such that c is between the start and the end of the interval. And if you plug c into the function, boom, 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 you will get y. Back in the days before calculators, the intermediate value theorem was a really good way to find zeros of a function. Keep in mind that when we're asked if a function has a zero, what we're asking is there a point where y is equal to 0? In this problem, we want to know if f of x has a 0 in the interval from 1 to 2. The answer is either going to be yes, no, or maybe. The first thing we want to do is plug 1 and 2 into the function so that we get the y values. The cosine of pi is -1, and the cosine of 2 pi is 1. So that means that f of 1 would be equal to -2, and f of 2 would be equal to 8. So if we picture this graphically, right here is 1. The value of the function is going to be -2. Right here is 2. The value of the function is up here at 8. Our answer is going to be yes. Even though we might not know exactly what path the function takes from here to here, what we can say is this. F is continuous on the interval from 1 to 2. Therefore, by the intermediate value theorem, since 0 is between -2 and 8, there is some x equals c such that f of c is equal to 0 on the interval from 1 to 2. So what we now have is a total of 3 different value theorems. There's the intermediate value theorem, which is the one that guarantees if you've got a continuous function that the function is going to hit all the y values between f of a and f of b. There's also the mean value theorem, which we learned last time. The mean value theorem guarantees that if the function is continuous and differentiable, then whatever the average rate of change is, the slope of the line connecting the two endpoints, there must be at least one place on the interval where the instantaneous rate of change is the same. Here's the third value theorem, the extreme value theorem. And this one says that if your function is continuous on a closed interval means that it includes the endpoints, then it is guaranteed to have an absolute maximum somewhere and an absolute minimum somewhere. And we learned last week that that has to happen at either critical points or at endpoints. Now, I do want to show you why the continuity is important. So here's 3 images. First one, notice that I've made it discontinuous at 2 places. Because this one is discontinuous, it fails the extreme value theorem. Notice that this has no minimum and it has no maximum. So that's why continuity is necessary. Good question. Second, let's talk about the intermediate value theorem. Here's a function where I've made it discontinuous at a point. And this one is going to fail the intermediate value theorem. And the reason is there's a y value, boom, 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 that the function never hits on the interval from a to b. Finally, continuity is also necessary for the mean value theorem. Recall that the mean value theorem is the one that says whatever your average rate of change is, whatever your slope is between the two endpoints, you have to have a point on the interval where the instantaneous rate of change is the same. Now, the instantaneous rate of change would be the same at this point, but the point doesn't exist. So, translation, continuity is important. And to open up this document that says value theorems practice. This is the practice that I want you to do. And that document, first, I gave you like a nice little reference for our 3 different value theorems. What I would like you to do is attempt right now question 0, which is going to ask you for each of these statements, is the statement referring to the intermediate value theorem, the mean value theorem, or the extreme value theorem? And then once you know which value theorem you're using it with, you are going to state whether it is true or false. So pause the video, go and do that. Okay. Now I'm going to assume that you have watched the video, and I'm going to draw a couple of different curves, one that looks like this and one that looks like this. By watch the video, what I actually meant is that you have attempted the true-false problems. So both of these are continuous and differentiable on the interval. And let's go through them to see whether each of these statements is true or not. So the first 4 statements here are all referring to the intermediate value theorem. A is true. The reason A is true is that 9 is right here. So by the mean value theorem, the curve has to hit 9 at some point. Now B is false. And the reason B is false is because while this one hits 11, 11 is not in the range between 1 and 10. So you can see the second curve does not hit 11. So B is false. C is also false because we see here that it could hit 11. And then finally, D is false because D says that it only takes values between 1 and 10. You can see that the second curve does, but that the first curve takes values that are outside of 1 through 10, like 11 up here. Okay, moving along. Questions F, G, and H are all dealing with the mean value theorem. Question F says that we know there's some point where the average rate of change is -3/2, therefore the instantaneous rate of change would be -3/2. Well, if you find the slope of this line right here, you will find that that average rate of change is -3/2. Same thing obviously here. That guarantees that there has to be some point here where the instantaneous rate of change would be equal to -3/2. Notice that while there's only one here, there's a bunch on this one, like there and there and there and there, and there's probably more. Okay, so that means that F is true. G is false because it says that the slope would have to be -3/2 everywhere, and that's not true for either of them. H is also false because H says that we are guaranteed to get at least one critical point. Now you can see that the first curve has critical points here and here and here and here and here, but this one has no critical points. Okay? So that finally brings us to I and J. I and J are both referring to the extreme value theorem. I says that we have an absolute maximum on the interval, and that is true because the interval is continuous and closed. So the absolute maximum would happen here on this curve, and it would happen here on this curve. So I is true, but J is false. J says that the absolute maximum value of the function on the interval is equal to 10. And that, in fact, is not necessarily the case, because while 10 is the largest value here, you can see that on this curve, it gets larger than 10.